Welcome to Chapter 6. Today we'll be talking about learning. We'll be learning about learning to, keep it cheesy. It's important to note here that this chapter, or at least this lecture, will be a little bit short. And that's because this chapter really focuses on a specific type of learning, and it doesn't necessarily cover the full complexity of the spectrum of how learning occurs, and that's because learning is very complex. So we're focusing on a specific type of learning that will also teach you about behaviorism, which is one of the foundations of psychology. And the reason that this textbook was actually picked for use in this class is because it's one of the few that actually even discusses behaviorism. And given that we are the nation's #1 program for behavior analysis, it seemed important to also include behaviorism in our Intro to Psych lectures. So that's why this chapter is a little bit shorter. And again, we just won't go into the full spectrum of what learning is, but this is a good introduction to kind of the basics. And I also want to draw your attention to the incredibly important piece of information over here. My niece is very cute, and this was her about 2 years ago at her preschool orientation. So what are our learning objectives today? What are our learning objectives? We're going to define learning, habituation, and sensitization. We will also differentiate between classical and operant conditioning. Then we will define reinforcement and punishment. And finally, we'll discuss some of the cognitive and biological mechanisms of learning. Again, we'll be touching on those instead of going into those more in depth. However, with that said, when we do the developmental chapter, obviously development also includes learning. So we'll touch more on, cognitive learning in that chapter as well. For any of you who were worried you just wouldn't learn enough about learning. So let's define learning. Learning is a lasting change in behavior or thought that results from experience. So this obviously covers a full spectrum of learning, right? It covers the full spectrum of our becoming more knowledgeable and experienced within the world. So this covers everything from remembering facts and names and faces and places to learning physical skills, learning things like how to walk, how to talk, how to play a sport. Additionally, it stretches all the way up to learning really complex things like astrophysics. Basically, nearly all of our behaviors are a complex combination of our genetic predispositions and what we've learned from kind of being part of the world. Here is another very cute picture of my niece when she was like, I want to say 9 months old there, maybe a little older. So let's first get into habituation. So habituation is the process of responding less strongly over time to repeated stimuli. So this is basically the simplest or perhaps earliest form of learning, and a lot of creatures on Earth habituate. So this is an adaptive function, right? This is an adaptive skill that we have because it means that we learn that we don't need to attend to everything. And for example, this was first discovered in a sea slug, and here is the sea slug over here, extremely cute. And what scientists found was that if you repeatedly touched the tail of the sea slug, it would react the first few times, but then over time, after you touch it, it stops reacting. It's learned that the stimuli is coming and it won't react to the stimuli anymore. So even if it doesn't necessarily have knowledge, right, like constructed knowledge of someone is touching my butt, it still has learned to kind of expect a stimulus, to expect that kind of thing. And right, that's adaptive. If the sea slug reacted every time somebody touched it, that would be a bit of a waste of energy. Once we've kind of learned the experience, we don't need to re-react every single time. So there's also an example, you can watch this on your own time. It's a baby being habituated to the sound of a rattle. So the first time the rattle goes, the baby kind of whips their head over to look at it, and the next time the rattle goes, the baby does not really care as much. It's already seen the rattle, it knows where the noise is coming from. It slowly becomes habituated to the noise of the rattle. Next is sensitization. So this is when we respond more strongly over time. So this happens kind of most often when a stimulus is dangerous or irritating. So, you know, let's say that we had been shocking the sea slug instead of touching it, right? Every time it would be shocked, maybe it would respond stronger and stronger and stronger as it got more bothersome to be shocked. Additionally, if you've ever been in, like, if you've ever worked in a coffee shop, sometimes being in the coffee shop is very nice. But if there's ever an annoying noise, it gets significantly more irritating over time. If you've ever had somebody who like annoyingly clicks their pen when you're trying to concentrate, or I had an old roommate who had a very bothersome chewing style. And probably the first couple of times I heard it, it didn't bother me, but then, you know, the 1,000th, I was sensitized to that sound. So now let's jump into conditioning. So conditioning is another one of those foundations of learning. And this was discovered by Pavlov, and you've probably heard of Pavlov in the context of Pavlov's dogs. So here's a cute little comic down here. You know, the dog is saying, watch what I can make Pavlov do. As soon as I drool, he'll smile and write in his little book. So classical conditioning, the actual definition of it, is that it's a form of learning in which animals, including humans, come to respond to a previously neutral stimulus that have been paired with another stimulus that elicits an automatic response. So if you give an automatic response to a stimulus, and that stimulus is always paired with something that's neutral, eventually if you remove the first stimulus, you then start having that automatic response to the neutral stimulus. So a good example of this, and I would show the YouTube clip, but it's a little annoying to kind of switch my lecture on and off. So anybody who's seen The Office knows what I'm talking about. But if not, this would be a good time to kind of pause me and watch the video. In The Office, Jim, one of the main characters, classically conditions his coworker to basically salivate at the sound of his computer booting up. Basically, every time Jim turned off his computer, he would offer an Altoid to his colleague. Eventually, he turned off his computer and he didn't offer the Altoid, and his colleague kind of reached out his hand looking for an Altoid. So the reaching out his hand isn't the automatic response, but the character ended up kind of salivating in response to the sound, and that would have been the automatic response. So in classical conditioning, there's a few kind of key terms to remember. The first is the unconditioned stimulus. This is the stimulus that elicits the automatic response. So it's just, you know, so in the Office example, the unconditioned stimulus, it would be the Altoid. Then there's the unconditioned response. This is the automatic response to a non-neutral stimulus that does not need to be learned. So this would be the fact that you salivate before, you know, eating a sour candy. Then you have the conditioned stimulus. This is the initially neutral stimulus that comes to elicit a response as a result of association with an unconditioned stimulus. So in the Office example, Dwight is now the colleague, is now responding to the sound of the computer. So the computer, like, kind of shutting down is the conditioned stimulus. The conditioned response is the same response in the, here, it's the same response, again, salivating in the example I was giving, but now it's elicited by the neutral stimulus through conditioning. So expecting an Altoid after the computer shuts down instead of expecting an Altoid, or salivating because the computer shuts down instead of salivating for an Altoid. So here's another handy diagram to give you a good idea. Dogs will salivate in response to food. They won't salivate in response to a tuning fork. You You pair the tuning fork with the food enough times, eventually the dog will salivate to the tuning fork. So this is exactly what Pavlov did with his dogs, was he used the tuning fork every time he gave them food. So there are 3 principles of classical conditioning that are important for you to know. The first principle is acquisition. Acquisition is the learning phase during which a conditioned response is established. So acquisition in the example of The Office were all of the times that Jim had kind of booted his computer up and then offered Dwight an Altoid. Extinction is the gradual reduction of and elimination of the conditioned response after the conditioned stimuli is presented repeatedly without the unconditioned stimulus. So eventually Dwight won't salivate every time he hears the computer boot down because it'll stop being paired with the Altoid. Eventually that response will experience extinction. Spontaneous recovery is another thing that sometimes happens, which is the sudden reemergence of an extinct conditioned response after a delay in exposure to the conditioned stimulus. So maybe one day, Dwight is working in a new office and somebody boots up their computer and all of a sudden he's craving an Altoid. That would be an example of spontaneous recovery. Something similar, but not exactly the same, is the renewal effect, which is the reemergence of a conditioned response following extinction when returned to the environment in which the conditioned response was acquired. So sometimes it's less about the fact that something was, went extinct, and more about the fact that you weren't in the exact same environment. So the dogs in Pavlov's dogs example salivate in response to a tuning fork, but maybe they don't, maybe they stop salivating in response to a tuning fork anytime they're outside, or maybe if they're being pet sat by somebody, or maybe when they're at home. But anytime they're in a laboratory, maybe the conditioned response will reemerge. It'll kind of show this renewal effect based on the environment. The next important term for us to know is stimulus generalization. This is the process by which conditioned stimuli that are similar but not identical to the original conditioned stimulus still elicit a conditioned response. So for example, with the Pavlov's dog example, they're responding to a tuning fork, but maybe they also begin to respond to sounds that are similar to the tuning fork, like bells or musical instruments. Any sort of high-pitched noise, maybe they begin to salivate to those too. The more similar to stimuli are, the greater response to that kind of neutral stimulus. So this is potentially adaptive, right? It's kind of efficient to learn generally so that you are prepped to respond to new stimuli. For example, let's say a child is bitten by a small dog. They might generalize the fear that they feel towards that one dog that bit them to all dogs. So that is generally adaptive and protective to do that, even if, obviously not all dogs bite children. But for a child, and even for an adult, it's kind of safe to generalize like that. Additionally, the opposite is stimulus discrimination. This is a process by which organisms display a less pronounced conditioned response to conditioned stimuli that differ from the original conditioned stimulus. Again, this is adaptive because it's potentially more efficient, right? We're not always responding to stimuli that are incorrect. So maybe Pavlov's dogs learned to respond to that tuning fork, and they knew which one it was because they, maybe it had a specific frequency, but they're not going to respond to all tuning forks. So although these run in opposite directions, they're both adaptive for different reasons. It's helpful to transfer knowledge, but it's also helpful to be efficient in what you learned. And often you need kind of lots of paired stimuli across varied stimuli in order to kind of, develop learning about categories instead of specific objects or specific stimuli. The next important term is higher order conditioning. So this is developing a conditioned response to a conditioned stimulus by virtue of its association with another conditioned stimulus. This is kind of the second order of conditioned. So let's say that every time Pavlov rang the bell, let's say he goes into the laboratory, he flips on the light, and then he rings a bell to let the dogs know that it's time to eat. The dogs might also begin to associate the flipping on of the light with the paired tone, and thus they also develop a conditioned response to that kind of to that unintentional stimuli. And it's just about that pairing, that association. Sorry, my slides are annoying to deal with. Sensitive keyboard. So classical conditioning is used in daily life all the time. So advertisers often pair pleasant stimuli with their product enough times so that you associate the product with the pleasant response you feel from the stimuli. So the example I gave is that CoverGirl pairs their products with, although they wouldn't anymore because she has her own makeup line, if you pair your product with Rihanna enough times, everybody who has positive feelings about Rihanna, which should be most of us, will end up feeling more positively towards the product. Additionally, this is kind of, I don't know if you've ever seen makeup commercials where everything looks like candy or chocolate. Most human beings like candy and chocolate, and they like sweets. So you pair those things together enough times, we'll start to associate the makeup with those good feelings we feel about sweets. Similarly, this happens with pairing just in general. They consider incredibly attractive people pleasant stimuli as well. So we associate their product with beautiful people. The difficulty that advertisers would have is with something called latent inhibition. So this is the difficulty we have in establishing classical conditioning to a conditioned stimulus that we've repeatedly experienced alone without the unconditioned stimulus. So basically, it's harder to establish classical conditioning with objects or ideas that we're already familiar with, right? We'd have to form new conditions. We'd have to kind of learn new things about something we were already familiar with. So let's say you've had a lot of Arby's in your life and you know what Arby's is and not necessarily a huge fan of it. And then you see an advertisement for Arby's in which they're pairing it with a beautiful woman or a beautiful man, depending on your preference. You'll remember what Arby's is and the pleasant feelings you get from looking at the beautiful person don't really make you want Arby's anymore because you know what Arby's is about. So what about how classical conditioning affects us in daily life beyond what we see in advertisements? Classical conditioning can affect our acquisition of fear and phobias. And how this was discovered was by John Watson, who is the founder of behaviorism. If you recall, we learned about him in chapter 1. And how he discovered this was with a baby who he referred to as Little Albert. Basically what he did is he instilled phobias in Little Albert, and he taught him to fear white rats by kind of putting a rat with baby Albert and then playing loud noises right next to Little Albert's ears to kind of scare him. And there's videos of this happening online, which I always find upsetting. But Little Albert ended up experiencing stimulus generalization. He ended up becoming afraid of not just rats, but also rabbits and cats and other types of kind of furry small animals. I also kind of wonder whether or not he was actually generalizing his stimulus, or he just became afraid of this horrifying man who was torturing him and who kept putting small animals next to him. So unfortunately, the sad end to little Albert's story is it does seem as though he did pass away when he was just a child. That's kind of what we know about him. Because people have been really curious, you know, how did this baby who was kind of tortured in the name of early science end up? And unfortunately, we probably won't know what the next, 7 or 8 years of his life were like. So although we can develop a phobia or a fear based on classical conditioning, here a few examples are things like thunderstorms. If, there's a bad experience with a thunderstorm, we might become more afraid of them. Little Albert developed fears from classical conditioning. Or again, if we're bitten once by a dog, it's probably good for us, it's reasonable that we'd be afraid of dogs. But we also have phobias for things that we don't have repeatedly paired experiences with, right? A lot of people are afraid of spiders, even though statistically, spiders don't bite people, and they don't bite them painfully all that often, especially compared to other things that we're not really all that afraid of, like, wasps or bees, or here in Florida, I was going to swear, freaking fire ants. I hate those things so much. I'm not from Florida, so I've discovered what I hate most about the state is the fire ants. So it's not really reasonable for us to be afraid of spiders, and most of us don't have significant negative paired experiences with them. But it seems as though there may be kind of a predisposition to being afraid of spiders. Similarly with heights, even if most of us, again, especially for people who are here in Florida, you probably have significantly fewer experiences being in like a high rise or, in high up locations, but you probably are, a lot of people are generally afraid of heights despite their lack of experience with them. So what that suggests to us is that there may be some genetic components to certain phobias, that we may be as a species predisposed to find kind of certain creepy crawlies scary and to find certain experiences scary as well. So what are the limitations of classical conditioning, right? So some of the limits are that classical conditioning is all about automatic responses and reflexes, right? We can talk about fear and things like feelings or emotions. Maybe we can pair a stimuli with feeling sad or happy, etc. Or body responses like salivation, or you feeling hungry, maybe even feeling turned on, something like that. But these are all automatic responses, but of course human behavior goes well beyond our automatic internal responses. We also have intentional behavior. So how do we account for that intentional behavior? We do that with operant conditioning. So operant conditioning is learning controlled by the consequence of the organism's behavior. So instead of our responses being shaped by being, previously paired with a stimuli and something else, instead our behavior is shaped by what follows it in terms of rewards and punishments. Another term for this is instrumental conditioning, but for the purposes of this class, I just want you to kind of pay attention to operant conditioning. But if you ever take other psychology classes, they might use these two terms interchangeably. An important term to know about within operant conditioning is something called law of effect. This is the idea that if a stimulus is followed by a behavior, that stimulus is more likely to give rise to the behavior in the future. So this was proposed by E.L. Thorndike after he did kind of a, basically a learning task with a cat. And I'm gonna play that video now. And what I've noticed now that I've edited the other videos that I included videos in, it could be a little jumpy. So if you did not enjoy watching that, I will also post this YouTube link on the module, and you can skip right ahead to when the video stops in this lecture and just watch the video on your their own, but this will be kind of required viewing here.
But how is a new skill learned? That was a question which began to fascinate Thorndike. To answer it, he built some ingenious puzzle boxes from which cats could only escape by operating latches.
And in you go.
The cat appears to be very clever in engineering its escape, solving the problem with a deftly placed paw and a push of its nose. But Thorndike didn't believe that an animal, even a clever cat, understands the consequences of its behavior. When he placed a cat in the puzzle box for the first time, Thorndike was unable to see any evidence of flashes of insight. The successful actions appeared first by chance. He proved that the apparent cleverness arose by trial and error, and used graphs to measure the rate of learning. A well-practiced cat quickly recalls the actions that help it escape to its reward of food. If an action brings a reward, Thorndike believed that that action becomes stamped into the mind. In his thesis, he explained further his ideas about learning, that behavior changes because of its consequences. He called this his law of effect, which explained how even wild creatures develop new habits.
So basically what Thorndike was demonstrating there was that these cats were learning through trial and error at first. They kind of stumbled upon opening their own cage through trial and error. And then they were learning to continue to do that action in order to continue to get treats because they were rewarded for that behavior. So after they got the treat the first time, they only became quicker and quicker and quicker at solving this puzzle because they began to learn how to do it because they were getting a treat. And again, he used this as evidence against insight. He really emphasized that the cats were learning through trial and error, not that they were grasping the underlying nature of the problem in order to solve it. Next, we'll talk about B.F. Skinner. He's another big name with behaviorism. B.F. Skinner designed the Skinner box, which electronically records an animal's responses and then prints out a graph. And it does that because it's recording the responses from a bar that an animal would press. So the bar delivers food when pressed, and often the food is delivered with a light that signals a reward. So if the animal pressed the lever, which is a conscious and intentional behavior, it would receive the reward, which would then change its future behavior. So anybody here who can predict the future could maybe guess that the rats are more likely to continue to press that bar in order to receive the reward. So we'll kind of pause here before we discuss conditioning further and in more depth. And we'll distinguish between operant and classical conditioning. It'll be really important for you guys to be able to distinguish between these two. And unfortunately, students do struggle with this. The two concepts can get mixed up in their head pretty easily. So we'll distinguish between, with operant and classical conditioning, we'll distinguish between the target behavior, the reward, and the behavior, what it primarily depends on. For classical conditioning, the target behavior is listed automatically, right? It's things like salivating, it's feeling fear. There are behaviors that are elicited automatically. The reward is provided unconditionally. Every time the stimuli occurs, the reward is provided. And the behavior depends primarily on our autonomic nervous system, right? Changes in heart rate, breathing, perspiration, etc. The actual behavior that, the salivating or feeling nervous depends on that autonomic nervous system that is outside of our control. With operant conditioning, the target behavior is emitted voluntarily. The reward is contingent on that behavior, and the behavior depends primarily on our voluntary motor behavior, not on our autonomic nervous system. So it's important to remember these distinctions. So when we talk about reinforcement and punishment, what we're talking about is specifically whether or not the target behavior increases or decreases, not whether or not the behavior is good or bad. Again, with positive and negative, it's about whether or not the stimulus is added or taken away, not whether or not it's good or bad. Again, it would be negative if you took a shock away from a rat, even though it's generally good and the rat enjoys that, but it's negative because it's taking the stimulus of the shock out of the picture. So some examples, again, just to kind of help you understand what each of these are. With positive reinforcement, the procedure is presenting a stimulus, and the effect is that it increases the target behavior. So an example of this is if you do well on your homework assignment, a teacher might put a gold star on it. So the stimulus is putting the gold star on it, and hopefully the student continues to do well on their homework. That's kind of the idea of it. Negative reinforcement is about removing the stimulus. So with negative reinforcement, you're removing the stimulus to increase target behavior. An example of this would be when the static on your phone subsides when you move to a different spot. So the stimulus of the static goes away because it increased the behavior of you moving. And if the static came back, you'd move again to remove the stimulus. Then we have positive punishment. So that's presenting a stimulus to decrease target behavior. An example of this is when you scold a dog to stop it from chewing on shoes or to stop it from doing anything. When you scold the dog, you're presenting the stimulus of scolding in order to get them to stop the behavior. Then negative punishment is removing a stimulus. So this decreases target behavior by removing the stimulus. So this is if you want a child to stop throwing tantrums, so you take their toy away. So you say, the next time you throw a tantrum, I will take your toy away from you. I will remove the stimulus to decrease the number of tantrums that you throw. So it'd be good to kind of memorize these, and it might even be helpful for you to come up with your own maybe personal examples just to help you clarify what each one is in your head. So when it comes to punishment, there are some disadvantages for punishment. So Skinner believed that punishment tells an organism what not to do, but doesn't really provide any more information about what to do. So again, you punish a child for throwing a tantrum, but the child doesn't have emotional control in order to understand how to deal with those emotions now. So telling a child to stop throwing a tantrum doesn't tell them much about how to deal with the complex feelings that toddlers feel all the time that they have very little control over. Additionally, using punishment can create anxiety, and this interferes with future learning. Additionally, punishments can encourage sneakiness, avoidance of getting caught instead of avoidance of behavior. So using punishment with children or animals instead of only using reinforcements can again interfere with future learning and maybe teach the wrong lesson, because by teaching somebody what not to do, we're not teaching them the correct lesson of what to do. Again, we're not saying do this behavior and you'll be rewarded. We're saying don't do that other behavior, you'll be punished. Additionally, certain types of punishments can provide a model for aggressive behavior. So children can learn through observation, and if they see enough kind of aggressive punishment, they're learning that aggressive behavior, again, instead of the behavior that we want children or animals to learn. So what about physical punishment? So something like spanking. So we were just talking about, regular punishment, things like timeout, things like taking toys away from children. And although generally reinforcement is better than punishment, sometimes punishment is a little bit of a necessity in, raising children. Again, timeouts sometimes can help children learn how to regulate their emotions. If kids are doing something dangerous, there's not really a behavior that they should be doing. They just should not be doing that dangerous behavior, right? I think it's totally appropriate to yell when a kid's about to touch a stovetop, right? Because we don't want them to touch the stove again. But when it comes to physical punishment, so something like spanking, is there an actual benefit to it? So generally what research finds is only negative effects. So this is a good chunk of the research finds negative effects, and there are some studies that don't find negative effects. But there hasn't been a single study that has found benefits to spanking. It doesn't lead to improved behavior, doesn't necessarily lead to improved well-being for children, at least not above and beyond how other forms of punishment or other forms of reinforcement behavior do. So generally, spanking is worse than most, studies find that it's either worse or no better than any other type of, way of disciplining your child. So probably not great to spank. With that said, though, it does seem as though the negative effects of spanking do seem to be cultural. So if it is typical within a culture to use spanking as a form of discipline, there are no negative effects, or there generally don't tend to be negative effects. If it is abnormal within a culture to use spanking, then there are significant negative effects. Again, never any benefits to spanking. So important information to learn. A few other important operating condition terms. The first is discriminative stimulus. So this is a stimulus that does signal the presence of the reinforcement. So in the Skinner box example, the light would come on when the rat pressed the bar and food came into the cage, and the light would be that discriminative stimulus. It's just another stimulus within the environment that signals the presence of then that reinforcing or the reinforcing stimuli. And then acquisition, extinction, spontaneous recovery, generalization, and discrimination. All of these terms that we learn about in classical conditioning also apply to operant conditioning. Again, because operant and classical conditioning are kind of part of the same idea. Another component of reinforcement and conditioning is the actual scheduling of that reinforcement. And what the schedule of reinforcement means is just the pattern of reinforcing a behavior. So when we talk about how best to train a dog, I think intuitively people might think that the best way to train a dog to do a behavior is to give it a treat every time it performs that behavior. But instead, what's actually better is to provide the treat intermittently. So provide the treat maybe every other time the dog does the behavior, because this can actually lead to slower extinction of the behaviors. And in part, this kind of has to do with the idea that, that if the dog knows it's going to receive the treat every time, if it doesn't necessarily want a treat right then and there, if it's not particularly hungry, it won't perform the behavior. But if you're never really sure about whether or not you're going to get a treat or not, you're motivated to kind of try every time because there's kind of limited resources to fight for. So there are a couple of different patterns. The actual terms for them include continuous reinforcement, which is that reinforcing a behavior every time the behavior occurs, and partial reinforcement. This is that occasional or intermittent reinforcement. So how do we actually schedule reinforcement? We can do this in 4 different ways, kind of broken into 2 categories. The first one is reinforcing based on amount of time. So the first amount of time schedule is a fixed interval. which is when we provide a reinforcer for a response at least once following a specified time interval. So for example, if you want to make sure your child is doing their homework, maybe you'll give them, you'll let them have a 10-minute break every, 30 minutes or so. So they get a reinforcer, they get a reward following the specified time interval, and that time interval remains the same. Variable interval, on the other hand, provides a reinforcer for a response at least once during an average time interval, with the interval varying randomly. So similarly, you want to provide your child with a break. So maybe the first break is a minute, and then the next break is 30 minutes. And then the break after that is 10 minutes. So that, it's really kind of more random variable intervals, as long as they're still kind of circling around an average time of, let's say, like 10 minutes or so. The next type of schedule are the number of responses. The first being a fixed ratio. So this is when you provide a reinforcer following a regular number of responses. So let's say you're training your dog to sit. Maybe you give them a treat every other time that they sit. So they sit once, you give them a treat, you don't give them a treat the next time, and then you give them a treat the time following that. So again, it's fixed. It is every other response. Comparatively, the variable ratio is when we provide reinforcements after a random number of responses. So maybe you give your dog a treat 2 times in a row, and then you don't give them a treat 5 times in a row, and then you give them a treat 1 time after that to really, keep them on their toes, right? So you're really providing variation with that ratio. If we're trying to kind of map out what the best schedule is for having consistent behavior, we can kind of compare how often a behavior occurs over time. And if you can't tell, so fixed ratio, if we have the fixed ratio where you're getting a treat or something or a reinforcer every certain number of times you perform that behavior, you perform that behavior a lot, and you kind of stagger it as well. With variable ratio, you also perform the behavior a lot. You really want those treats, right? So you just kind of just continue, giving the number of responses as quickly as you can because you want more and more reinforcers. With fixed interval, again, this is about time. There's kind of leveling off of responses of behavior as that time comes closer, right? So say your kid is supposed to work on their math problems for a few minutes. Maybe they don't do any math for a bit, and then, our 5 minutes is coming up, let me get some done. Then they don't do any math problems, and the 5 minutes is coming up, so they get some done. So this doesn't really provide rapid responding. Comparatively, the variable interval does provide steady responding over time for a longer period of time than any of the other type of responses. However, with that said, whether or not you're giving reinforcers via time or via behavior, it probably also depends on what type of behavior you're looking for, right? For a dog sitting, it probably doesn't necessarily make sense to do it time-based, right? Because you're not going to ask your dog to sit for you 100 times in a row so that you can give them a treat every 5 minutes or so. But there's other types of responses that intervals work better for. So how do we apply operant conditioning in the real world? So the examples I'm giving a lot today are animal training, right? Animals are shaped really easily by conditioning, and we condition their target behaviors by positively and progressively reinforcing their behaviors that come closer and closer to the target. So if you've ever, again, I'm just going to keep, if you ever trained a dog to lie down, kind of how you do it is you get them to, you kind of hold a treat to their nose and you guide them to lie down, and then you give them a treat for doing that behavior. And eventually they kind of figure out which behavior gets them the treat. Similarly, with those more complex behaviors, how you train a dog to do something is they kind of half do the behavior and you give them a treat. And then the next time they have to do the behavior, you don't give them a treat, and then they have to do 75% of the behavior to get the treat. Additionally, operant conditioning is how slot machines work when you're gambling, right? A lot of them work on kind of these variable ratios. So a lot of them work in a way that is maximally addictive. If we go back to this chart here, using a variable ratio makes people continue to input the behavior. This represents kind of addictive behavior here. We'll continue adding into the slot machine in hopes of a reward. Now we'll talk about the token economy. So what is a token economy? So how a token economy works is that we, you'll make tokens that are normally meaningless valuable and use them for positive reinforcement. And we end up kind of creating this economy or system for reinforcing appropriate behaviors and extinguishing inappropriate ones with the tokens. So the token economy is a type of operant condition that is used commonly in clinical settings. So it's used often with children with autism. And if you want to know like more specifics about the token economy than what I will give you in this lecture, you can talk to any one of the behavior analysts who work within our department here at UF. So how the token economy actually works is through primary reinforcers and secondary reinforcers. So a primary reinforcer is an item or outcome that naturally increases target behavior, so favorite food or drink. So with a lot of research that's done with children with autism, sometimes they motivate them with their favorite candy, right? So if they perform the behavior, they get Skittles or M&Ms or something like that. Then there are secondary reinforcers. So these are objects that become associated with that primary reinforcer in the form of tokens, chips, or points, or something like stickers for my niece. So what ends up happening is that children can, or people in these clinical settings can earn tokens, which then can kind of buy these primary reinforcers. And that's how this little economy gets built. But of course, it's important to note here that the reinforcers need to like matter to the individual, right? A child who doesn't like sweets earning M&Ms, that's not very fun. So maybe they need to earn chips or something instead. So this obviously doesn't just work with children with autism or in clinical settings. My niece has a sticker chart that she follows because she loves to earn little prizes at the end of her sticker chart for good behavior. So after all of that talk about conditioning, can you think of whether or not there are limitations to conditioning, right? Are there times when we aren't explicitly reinforced? Are there other ways that we learn without having to kind of do trial and error and experience something behaviorally and then have some sort of reinforcement? And the answer is yes. A strict behaviorist would tell you no, but luckily strict behaviorists don't really run the field. But it does seem as though some things are learned through things like cognition, right? Our thoughts, observation, and insight, our own insight, right? So let's discuss a couple different cognitive models for learning. The first is the SOR framework, and this is something we also kind of briefly touched on in chapter 1. But the SOR framework is basically the stimulus response framework, and the idea is that when something learns, there is a stimulus, an organism, and a response. So the organism's interpretation of and expectations of stimuli are also important, right? So kind of like we were talking about the mind being a black box, there's still the interpretation that has to kind of happen in order to create the response. So a good example of this is, constructive criticism is really helpful for people to learn, but people have varying degrees of responses to criticism. So somebody who maybe likes their teacher and generally is affable when it comes to criticism and is accepting of criticism, compared to somebody who might think of themselves as kind of already knowing everything and not needing any extra help, if they both get a paper back and they both receive a B and they both receive a ton of comments, the first student is more likely to learn from those comments over the second student who might not actually, even if they read the exact same comments, they might have, widely different abilities to learn from those comments. The next model or cognitive model for learning is something called latent learning. And this is just learning that isn't directly observable. And specifically, it's the distinction between our competence and our performance. That sometimes we are competent in something and we've learned a skill, but we're not necessarily showing it, right? We're not necessarily demonstrating that skill constantly. And the evidence for this came from this study of rats in a maze. And what they found is that rats can create the actual cognitive map of the maze without reinforcement. So what they did is they had 3 groups of rats, one who were reinforced the whole time. The next group had delayed reinforcements. They had to run the maze 10 times, and then they got reinforcement after that 10th time. And then trolley rats, so rats who never received reinforcement. I actually think there are 2 different studies. Your textbook talks about just a group that never received reinforcement, but there's also another study where there were rats who were actually observing the maze. And what they found was that the delayed reinforcement rats and the rats who never received reinforcement committed errors every time they ran through the maze. They took wrong turns, etc. Whereas the reinforced rats slowly got better and better and better at performing the maze. As soon as they introduced a reward to the delayed reinforcement group, so this group had been making the same number of errors pretty consistently, as soon as they introduced a reward, their number of errors dropped way down at about the level of the consistently reinforced rats, which meant that these rats had been learning the maze the whole time, even without reinforcement, but had never really been motivated to complete it without error. And so in the study in the book that's discussed, again, they are talking about, they talked about 3 groups, one of which didn't receive any reinforcement at all. But in another version of the study, they also had rats who were in a trolley actually observing the maze, and they showed that they also performed the maze above what you'd expect, given that they hadn't run it before. So the trolley rats were learning from something called observation. The next piece of evidence that there are sort of cognitive models for learning is from something called observational learning. And this is when we learn from watching others. So we model each other's behavior all the time, and so do animals, right? So take this little girl, for example. She didn't learn how to sweep because she slowly touched the broom and her mom said, "Good job." And then she picked up the broom and her mom said, "Good job" again. And she slowly developed the behavior and the mechanism to sweep, right? She watched her mom do it, so she tried herself. So that demonstrates that we do model each other's behavior. And one of the required videos this week that I won't actually kind of force us all to watch during the lecture, but you can watch in your own time, is the Bobo doll study, which demonstrated that children can learn aggressive behavior from watching an adult perform that aggressive behavior. So in the video, you'll observe adults kind of attacking this Bobo doll, and then children mimicking the same actions that the adults had done. Unfortunately, some of what came out of the Bobo doll study was this idea that any sort of aggression in media, like video games, TV, and movies, was bad for people, and that people would mimic that behavior. But there's really no evidence for that. So although children do model behavior, they do seem to recognize the difference between pretend behavior and actual behavior, specifically in terms of aggression as well. Additionally, children choose to model behavior based on the behavior's outcome, right? So if the adult was punished after being aggressive, children won't model that aggressive behavior. But if somebody was rewarded after being aggressive or nothing happened, the child might end up kind of picking up a few of those behaviors. We also have biological evidence for our ability to learn via observation. And this evidence comes in the form of mirror neurons, which are cells that are in our prefrontal cortex. I'm sorry, I gotta pet the cats. They're cells in our prefrontal cortex that become activated both when an animal performs an action and also when it observes the action being performed. Again, indicating that there are cells that light up kind of in because our brain is actually mirroring behavior of others. Mirror neurons are also associated with our ability to feel empathy, so they will also light up at the emotions of others. The next sort of demonstration of a cognitive model for learning is something called insight learning. So this is the experience that people have where suddenly they feel as though they have a sudden understanding of a solution to a problem. So these are people's kind of aha moments or eureka moments. And there's a video here of insight learning that I would recommend. And actually, I would say we're not going to do the thing where we embed this video into the lecture either, but I would say pause here and watch the video. But a lot of the insight learning work came from animals who had demonstrated learning without ever doing trial and error. However, some strict behaviorists say that studies done on chimpanzees and apes can't rule out the trial and error because we didn't observe the apes the entire time. And also we can't rule out observational learning with these apes. However, when it comes to humans, I don't really know what the kind of hesitation is on saying that humans have insight learning, because I think we could all subjectively describe a time when maybe we put two ideas together to come to a third novel idea. I'm not a strict behaviorist. Now we'll move on to evidence that we have biological influences on learning. Again, more evidence that it is not simply conditioning, which is why we learn. So the first is conditioned taste aversion. So this is when we have an evolutionary predisposition to avoid foods that cause a bad experience. So this is obviously advantageous, right? It's good to avoid poisonous or rotting food. And this differs from classical conditioning in 3 ways. So I know that right now what you might be thinking is, if I eat something bad for me and then puke afterwards, isn't that a positive punishment that will decrease my behavior? Sure, but this is significantly different from classical conditioning because A, you don't need repeated pairings to develop the aversion. You only need one trial, you need one bad experience with a type of food to not want to eat it anymore. Additionally, the aversion isn't, the illness isn't immediate, right? There's often a delay between eating the food and the vomiting and other horrible things. So the delay between the stimulus of the bad food and the unconditioned stimulus of bodily functions can be as long as 6 to 8 hours apart. So for example, I actually got a stomach bug this past winter. I didn't actually experience food poisoning, but I had eaten broccoli cheddar soup for lunch that day, and when it was 8 p.m. and I was throwing up, my body kind of developed the aversion to broccoli cheddar soup, and it still grosses me out today. I only needed that one experience to never want to eat broccoli cheddar soup again. And it wasn't immediately afterwards that I threw up. The delay between the two was quite long. And interestingly, I'd actually eaten something else right before the vomiting. And I did not develop taste aversion to that, because the biological mechanisms in my body know that it wasn't the smoothie I ate at 7 p.m. that made me throw up, that it was more likely to be the broccoli cheddar soup. In reality, it was because children bring, a ton of disgusting things home from preschool, and the preschooler got the entire family sick. Additionally, conditioned taste aversions tend to be remarkably specific, and there's little evidence that there's stimulus generalization, which is something that does happen in classic conditioning and operant conditioning. So more evidence of the biological influences on learning. The first is instinctive drift. So this is the process through which animals will actually return to innate behaviors following repeated reinforcement. So instead of animals learning a new behavior and kind of retaining that new behavior as they continue to be reinforced, animals' instincts kind of bleed into their behaviors. So they actually, the evidence for this was initially found because they had taught chickens how to dance, and the chickens would continuously do the dance until after a while they started to incorporate their own kind of chicken motions into it, right? They started pecking at the ground and scratching at it, even though that wasn't part of what they had been reinforced to do. If classical conditioning was true, presumably they would just do what they had learned and not incorporate any new kind of instinctive behaviors. And this is true for other animals as well. That instinctive drift does tend to happen with these, despite repeated reinforcement. The next piece of evidence is something called preparedness. And this is our evolutionary predisposition to learn some pairings of feared stimuli over others, depending on their actual survival value. So how this was discovered was they found that you could teach monkeys to be afraid of a stimulus if you showed another monkey through a video being scared of that stimulus. And what they ended up finding was that monkeys would learn how to be afraid of snakes after only one viewing, but they would take multiple viewings to learn to be afraid of flowers. So it was much easier for a monkey to develop a fear of the thing that has a evolutionary survival value than the thing that isn't evolutionarily triggering at all. Again, this is a good explanation for phobias that we discussed earlier in this chapter. It's easier to develop certain phobias over others. So things like snakes, spiders, cliffs, those are more understandably, it's easier and more common to have phobias of those things than phobias of, bubble wrap. That's a phobia that people have. But there's fewer of those people, and it's harder to develop those phobias than the ones that are evolutionarily adaptive. So again, preparedness provides additional evidence that conditioning is not the only mechanism through which we learn. If we only learned through conditioning, we would learn all pairings of stimuli kind of at the same rate, but we don't. So clearly there is some sort of biology beyond conditioning. So now we'll discuss the different kind of fads and myths about learning. The first was a fad called sleep-assisted learning, so the idea that maybe we could learn while we're asleep. And people would play audio recordings of new languages. They would play audio recordings of somebody telling them, to be more confident. If you wanted to learn math, maybe you could pop on your textbook as an audiobook. So one of the problems here was that what they found was that people would be kind of half asleep or having their eyes closed while they would listen to these audio recordings, but that they weren't actually asleep. So any learning that it was occurring from sleep-assisted learning was when people weren't actually asleep. And the evidence suggests that when people are actually asleep, they don't learn any new information at that time at all. The next learning fad is something called accelerated learning. So this is one that I see a lot, that to learn better, there's certain techniques that you can use that will really accelerate your learning. And this goes beyond, tips and tricks for memorization or tips and tricks for study skills. It's things like if you listen to classical music, that music is somehow better for your mind and will accelerate your learning. So that evidence came from one study that had a limited number of participants, and they didn't actually study, compare people who, they didn't actually do an experiment or even a correlational design to figure out, exactly what are people listening to and how much do they learn when they're listening to that music. Instead, the study that kind of blew up and blew into the pop psych knowledge was that people who listen to classical music might learn better than those who don't. And obviously there are all sorts of other factors involved with who's listening to classical music or who has that preference above and beyond, that classical music is somehow priming your brain. Additionally, meditative breathing, it doesn't seem to be a way to accelerate your learning either. Next is discovery learning. So discovery learning was an idea that was kind of proposed and implemented in schools. And the idea was that you could give students materials and ask them to figure out concepts all on their own. And they were thinking, oh, it's hands-on, children are teaching themselves, and that'll kind of help them learn scientific thinking. And what we found is that it may have some use for children to kind of learn on their own and teach themselves scientific concepts, but overall, that seems to be less effective than their teacher kind of lecturing them and giving them direct instruction on how scientific thinking works and how projects work. It might be helpful for teachers to lecture on material and then have students then do those materials themselves or like do the experiment themselves. But having children kind of figure it all out on their own doesn't seem to be any more effective, if not significantly less so than direct instruction. The next learning fad that is pretty popular is the idea that individuals have learning styles, that people have optimal methods of acquiring new information, including some people are visual learners, they learn better from movies, pictures, etc. While others are verbal learners, they learn better from hearing and reading. Compared to spatial learners, they learn best when they're up and moving around. People don't have these styles. Instead, people are probably not purely one style of learner. Instead, we learn in all of these ways. We learn in visual ways depending on the medium, or verbal ways depending on the medium. And of course, I kind of just said it there. I gave it away. Context matters here. For certain concepts, visual works best. For other concepts, verbal learning works best. If you are, trying to learn a sports play, maybe visualizing it and seeing it drawn out is easier than verbally learning it, just having someone tell it to you. But probably playing it on the field, this kind of spatial learning and doing it with your own body is probably the easiest way to learn the play, right? So there are different ways to learn, but people don't have specific styles. So in general, a lot of the learning fads are flawed. They have generally a lack of evidence. And again, if somebody is telling you that this is the new way to accelerate your learning and to become an expert on something, you can just kind of tell yourself, extraordinary claims require extraordinary evidence, and a lot of these learning fads do not have extraordinary evidence. So some conclusions for today. We spent the biggest chunk of the day talking about the behavioral mechanisms of learning. And this included operant and classical conditioning, and we learned all of the terms that go with these two types of learning. Additionally, we learned about the different schedules of reinforcement. Then we discussed the limits of classical conditioning, or just conditioning in general, kind of through our discussions of the mechanisms or other root types of learning, including cognitive, observational, and biological. Additionally, we briefly debunked some of the learning myths or learning fads. So again, our discussion of other types of learning was a little limited today, but luckily we'll discuss more we'll kind of touch on learning a little bit more in the memory chapter and in the developmental chapter as well. But behaviorism is incredibly important and is really a foundation for a lot of modern psychology. So it's good that we spent as much time as we did learning about it, and it will be, important for your quizzes and stuff. So thank you again for listening. Hopefully there weren't too many kitten interruptions today. So yeah, thank you.